spinning bucket as it goes around. So now I want you guys to sit back and look at the problem and analyze it for me. So what was our force of tension of the rope when it was at the top?
2.6.
2.66 newtons. What's my force of tension at the bottom?
1.2.
So it's just like a roller coaster. If my top tension is more than my bottom tension, or in that case normal, it's going to derail. Right? So if the reason being is we're going to have this thing here, because does it make sense since that rope, I'm actually flinging it down, that I have to lift it up like this and then it's just kind of keep going when it's at the top. So there's less force of tension on the top because it's going to keep spinning around than there is at the bottom. So be able to look at your numbers when you're done and explain to me what that means. If you were Barbie, and I'm not talking about velocity when she's spinning off, but let's just say this. This is a bucket, which I can't remember what I did with my bucket. Envision a bucket. If there is a precious egg, an ostrich egg, that's worth hundreds of dollars, and some little smart aleck kid was whipping it around in a bucket, where would there be less chance that the egg would break if it fell out of the bucket? Top or bottom? I'm saying that it's going to release, it's going to come out of the bucket. Then don't tell me on the bottom, this record is probably not going to come out of the bucket. I'll give you a hole in the bottom of the bucket, okay? But if it was spinning and it came out, and because of the force, it should be going to the center of this, right? Mm-hmm. So if this, ouch, that was that paper clip holding it. If this was sitting like this, and we're going to say if something falls out of the bucket, where should it fall to if I'm dealing with the force, not the velocity?
Center.
To the center. My question is where would it experience more force? Meaning, where would it have a bigger advantage to break? The bottom. Because there's more force on there. And more acceleration. If I was able to pop it out and send it to the center.
And if
Okay.
you drop it from the top, you can just catch it on the bottom. Sorry. Or drop it and catch it. Yeah.
So be cautious. Again, today in your review, we drew 3 scenarios up on the roller coaster. Be careful if you understand the difference between if this is a track, that I could have a cart on the top, cart on the bottom here, and then I could say what happens if it's flipped like the corkscrew. Can you do a problem like this and set it up with the Y forces? Because in this case, what's going to happen? Remember, because the normal, they're both going down again, just like we just did, right? And in this case, it's normal because I'm dealing with a roller coaster, so you're actually sitting down, and there's a surface. Okay? In this case, I have the normal force going up and the gravity going down, and in this case, it's the same way. But then I'm going to ask this. When you figure out the net force, what are you going to do here? Add them. What are you going to do here? Which way?
FG minus FN.
Which way here?
FN minus FG.
We're all clear on that because that's been tested before and lots of problems on this. We get that. Again, roller coasters, buckets flying around in a vertical thing. It's the only type of vertical we're going to do. Everything else is going to be horizontal. Okay?
Took a lot of work.
Caitlin?
10B.
What?
Number 10B.
Which one's that?
I would say the satellite to get to revolution.
A satellite is orbiting. Did you guys get a different answer than it I did? Because I was kind of guessing.
Yeah.
You guys were walking into the door when I printed it off, so I was throwing numbers in. So everybody got the speed? Then I never went back and finished this, so this is 10B. So we did the height, so you guys found the velocity. I'm just making sure for 10A we're all good with the velocity being 2.8 times 10 to the third meters per second, or 2,080 something, 800 something.
And with that, would you use velocity?
Because I use this equation, velocity of the satellite is equal to the square root of g times mr.
So the g stays the same from
G
anything
6.67, yep.
for everything. Like
Okay, so now I'm going to letter B. What's my period? Period of a satellite is what?
2 pi square root of
2 pi times the square root of r cubed
over g.
over g
Or g, yeah.
times mass. So 2 pi. Here's my question is, what'd you guys get for the radius here?
you got like 2.43 times 10.
So be careful because the radius of Mercury was 2.43 times 10 to the 6th. But my satellite was above and beyond that. So you guys added that to that, right? So my true radius should be 2.68 times 10 to the 6th meters cubed. I can backtrack if you want me to. Okay. So I'm going back to the beginning of the problem. The height said that this thing was 245 kilometers above Mercury. Okay. So if I'm looking at the fact that if this is Mercury and my radius of Mercury is here, and then I have this satellite going 245 kilometers above that, Bailey, when I actually when I actually figure out the radius of this whole thing, I'm going to have to take the radius of Mercury plus the distance the satellite is. And remember, this 245 schmick, remember this 245 kilometers needs to be changed to meters. So if I change this to meters, I have to do what? So 205 kilometers is how many meters?
2.5.
I have to move my decimal place 3 places. 1, 2, 3. So 1, 2, 3. If I do this, it's 2.45 times 10 to the 5th meters. Do I have to keep going to B, or are you good? That's how I found that radius. You're the one that asked and you're talking. So I've added 2.45 to my radius of Mercury, which I gave you as 2.43 times 10 to the 6th. So I added that. To get this. Can I continue with period? I have a feeling my answer's wrong. Everybody did it right. If we got all the same answer, but I still want to continue for people who want help with it. Over
Oh, gotcha.
6.67 times 10 to the minus 11th Newton meter squared over kilogram squared times the mass of Mercury, which I gave you.
3.2 times 10 to the 23rd.
3.2 times 10 to the 23rd kilograms. Now, let's figure out your math to make sure you guys can do this if you have this on a problem tomorrow. It's probably better than what Miss Rickard did in 20 seconds before you walked in the other day. I probably didn't take the square root of the whole thing now that I'm thinking about it.
It always escapes my mind.
950 seconds. 950 seconds. 949.7 seconds.
Yeah, you multiply by 2 pi.
What?
You don't multiply by 3 pi.
So I took the cube of this
And the 2 pi.
divided by this. Oh, I forgot 2 pi.
And square root.
I did the square root. 5,967.
I got 1.9 times 10 to the 27th.
1.9 times 10 to the 27th.
Yeah.
Let me try that one again. 2.68 exponent 6. Y to the x is what I'm using, right? To do my cube on my calculator, because I never do cubes. Right? Is that what I'm doing?
Carrot key, yeah. Wait, what?
Okay, so when you do your caret key, stop. When you do, I just want to make sure that I'm putting my calculator. When you guys do this 2.68 exponent 6 and take the cube of it, what do you get for an answer? Put that in your calculators. Because I never use the caret key, I want to make sure, because y to the third should be the same answer.
1.92 times 10 to the 19.
And I got that.
Well, the velocity is just g.
Divided by
So
6.67 exponent
Divided by the radius
negative
of
11.
Mercury.
Divided by
2.2 to
3.2
the 6.
exponent 23 equals, before I take the square root, I got some big number, 9 times 10 to the 5th. That's before taking the square root. 9.02 times 10 to the 5th. Then I'm going to take the square root of it, and now I'm going to take it times 2 pi. I'm still getting 5,967.
Yeah. Well, I got 5,962. If I'm off by 5, do I still get it wrong?
So 5.97 times 10 to the third, same idea, right?
But how did you get it?
No, I didn't.
I
So the first time,
think I know why your answer on the back was wrong.
and then I divided it.
What, Josh?
I think I know why your answer on the back was wrong.
Give me a radius.
This is,
Because,
well,
when you were in
I
the
went back.
I'm pretty sure this is the radius of it.
1.7 days, that was only
Wait,
Okay.
I know, it's just for some reason I don't think I have this answer. Ah, that's what my case is.
Yeah.
Well, that's why, I don't know. That's why.
Yeah, because I got this answer too, and then I converted it. So then when I converted it, I just did it in my calculator without showing work. See, I have to show my
You
work.
just gotta divide by 24.
Square root.
5.
When you put it to the negative 11, isn't it the same if you multiply it by, like if you multiply
So we got
0.68?
You have to take this number, divide by this, divide by this in your calculators, because they're both denominators.
But no, what
Maybe
I'm
something
getting
else
at
in
is
the
like,
calculator.
isn't, because my calculator won't work with the negative 11. So isn't it the same as if you multiply it in the top, so
No.
isn't it
No.
like kind of,
No, because taking this would be 1 over, so you'd have to do 1 over 6.67, and then take it to the 11th power. You're gonna say, can I flip this up and make this to the
yeah, and
11th
then
power?
make it, yeah, just to be.
Here's the question, what is the reciprocal of 6.67? Because you'd have to take the reciprocal of that too.
Okay.
How is your not to the
Here we go.
negative 11 not
I
working?
got it now.
I don't know, it wasn't working when it kept coming up with syntax error when I was putting it in before. So I tried just flipping it around and that may be back.
So could you just leave it 1 second?
Yeah, I'm just checking my work notes.
Okay.
Yeah, so 0.07 days then, if I actually did it by that way. Yeah, I just wanted to know, for me, I'd like to know what does that mean in a day.
got 2.8 though.
Yeah.
As long as I see your units, I'm okay with that.
Okay, so if you convert everything to like
Round up
meters,
here.
and then your answer you'll know will be in seconds.
Yes, because let's go back. That's a great question. What is a Newton? Think about this. Newton is a unit of force, which is mass times acceleration. Therefore, what is a Newton has to be a kilogram times meters per second squared, divided that. Because we're going to declare that a meter then and a kilogram and a second is my unit for Newton. And that is why we always have to make sure our mass is in kilograms, our length is in meters, and our time is in seconds when you ever see a Newton. Which 90% of the time we're dealing with force, so let's just always do that in physics. And if I look at my math right here, kilogram goes away. This meter squared goes away because this would be meter cubed. That goes away. And I'm going to have a Newton, meter on top, Newton, and a kilogram here, which is kilogram meter per second squared. I'm going to have a second squared right here, and I'm going to take a square root of that, and it's going to be second.
So periods always
Just
in
trust.
seconds.
Period's going to always be in seconds because we're using newtons.
For one big. Right. That's not gonna be our test.
Anything else?
Oh yeah.
The coin rests on the record 0.3 meters from its center. And I'm assuming some of you guys have seen a record player before that just keeps spinning. I know it's old news for you guys, but I grew up on it.
What's a record
Okay.
player?
The record turns on a turntable that rotates at variable speeds. The coefficient of static friction between the coin and the record is 0.25. What's the maximum speed? So I'm going to tell you that right now I'm going to look at the top view of this. I have a circle with the radius 0.13 meters. I have a coin on this at this point. Here's my coin. Okay? My mass of this coin, they gave it to me, right? Oh, they don't give us mass on this one. My friction is 0.25, coefficient of friction. And they want my velocity of how long will it take before this. So when I look at this, I have to draw my forces of this coin. So what's going on with my coin? If I look at the side view of this, here's my record, here's my coin. So I'm saying this is the flat part. So what's going on here? What are my forces?
Gravity.
Is it sitting on a surface?
Yeah.
So that's a normal. And what's keeping something
Friction.
spinning here? So my force of friction is here. So here is my force diagram. So again, since I'm dealing with forces, and I see friction